In this video, we're going to see how can we combine, let's say, semantic search and GPT-3, which results into the powerful combination that revolutionizes the way we search for the information. So what exactly is semantic search? So semantic search allows us to extract the most relevant information from the set of documents that you have. Now, what are those documents? Those documents could be a web pages, your PDF file, your company internal documents. It could be anything. It could be even transcription of some audio or videos that you have, right? So when you combine semantic search and GPT-3, which results into the powerful combination, and I'm going to show you first the demo that what exactly we're going to build. So we're going to build an Intuit application, which going to use this all these things. So let's look at first the demo. So this is the demo of what we exactly going to build. So what you are looking at is actually, a Streamlit application, and you could see it has two options. So for example, you can ask a question with respect to whatever documents you have, or even you can update your database, or let's say the document store with the new documents, right? So let's say I have already put this particular Wikipedia article document inside the our vector store, and we can ask some questions with respect to this particular documents. I will show you the demo. Let's say if I ask, who is Sachin Tendulkar, and let's say what it does. So it started searching for the answer, and it find out certain context, whatever the documents we have. Don't worry, I'm going to show you how we can put this document. And now it is saying, Sachin Tendulkar is a former Indian cricketer. This is the greatest batsman of the Indian history, and all this information what it has extracted. So this is the answer. So what happened actually when I asked this particular query, it uses semantic search and find out what is the most relevant document which can answer this question. And when I get that document, I get this document is nothing but, let's say, some text chunks I got from the whatever the document store I have. And then I take this context and I take this query and give it to GPT-3 and ask extract the exact answer, or maybe the construct the answer. And we're going to see now what if, let's say, I ask like who is Cristiano Ronaldo, and see what happens if I ask this thing. And then if I submit the request, again it is searching for the answer. It has found some context, which is, let's say, whatever the most matching, because we don't have any threshold. But it is saying that the context is not sufficient actually to answer this query. So whatever the context it is able to find from our document store, it is not. So let's say, what if we want to update our document store? So let's take this URL, because we can take this URL and we can update our document store. So it takes an URL, and when you submit, what happens, we take this URL, we scrap all the text available, and then we insert that particular text as an embedding inside the vector database. And eventually, once we insert those documents and that information, then you can now ask question with respect to those particular documents. So it is still updating, because we're going to create those embedding using transformer library, and all these things, and it might be installing now, let's say, or loading my model, so it might take the time. And it's perfectly fine, so I'm skipping certain steps in the middle what is happening, but that's what we're going to see during the coding part of it, right? So don't worry about all these things. Okay, seems to be a document is very big, and I see these are the batches of insertion happening. That's why it is taking some time. Let's go back here. So that is in the background. I could see it is updating a lot of things. Okay, now the database is updated. Now let's look at an ask now question, because we know now we have information about, let's say, Cristiano Ronaldo. And if I ask now, sorry, let's go here. Yeah, here is where. Who is, let's say, Ronaldo, and it can answer the question based on whatever the information now it has. Now, if you see, it is able to answer this thing because it is able to find the relevant context inside our document store, and we can ask specific. Okay, maybe we can ask how Ronaldo began his career, something like that. Let's see. We get some answer for it. Like, let's say we ask how Ronaldo began his career, maybe only this thing, and let's see what relevant information we can get. Let's submit this thing. So Ronaldo began his career with this particular thing, where his father was Kitman. I don't know. Maybe the most relevant thing he found is something related to this, right? has began his career with this particular thing from 1992 to 1995. Maybe let's search this whether where it comes in the document as a child. Okay, so it find the most relevant thing is actually from his childhood, when he started kind of thing. So this is what the most relevant thing, it got the starting kind of thing. And if you look at the context, what we have, so we got this context, right? Yeah. So this is one of the contexts which is matching, and maybe I need to see how many contexts we are retrieving. But okay, this is how it actually works, which is going to find the exact answer for you. Now let's go to the code. Now this is a Streamlit application, but actually I want to give you walkthrough first to the Google Colab notebook because it is easy actually to write and show you the code there rather than going into the VS Code or something. So here is our notebook. What all things we're going to require. So first of all, for web scraping, we are using request library, and then let's say a beautiful soap. So this library get, let's say, the text of this particular or the web page we get using request library, and the beautiful soap extract the plain text from that HTML content. Then we take that particular content what we got here and we use embedding, right? So we use sentence transformer, we calculate those embedding, and then eventually we store those embedding inside the Pinecone. So when user ask any query here, for example, when you ask something here, what happens, we calculate the embedding using the same, let's say, sentence transformer model, and then we check against vector db and find the most relevant document. So since both are embedding, we use vector search, let's say cosine similarity, and find out the most relevant document, and then eventually we pass that document to, let's say, GPT-3, and the UI we just saw, we have a Streamlit. So let's go to here, and let's install the relevant thing what we require. So we require sentence transformer, we require a Pinecone because Pinecone is the vector database that we are using, and we also require OpenAI because we're going to use GPT-3. Now if you are not familiar with the sentence transformer, the Pinecone, and the OpenAI, I would suggest, I have one video for each of them. So I have video dedicated for, let's say, sentence transformer that you can go and see, and then I have one video where I introduce what is vector databases and how to use the Pinecone thing. In this video I'm going to show whatever the relevant information we're going to need, but if you're interested, I would suggest go and watch this video. And then I also have a video with introduction to it, let's say GPT-3. So if you want to get those relevant other videos, you can, I am going to share this document so that you can go and find this thing. And don't worry, I'm going to cover whatever the necessary for this particular video, and it might become long actually, this video. So let's look at now code. Let me zoom a bit, right? And you could see we're going to import the Pinecone here. We want sentence transformer, and we're going to use some utility because we want to, let's say, do some cosine similarity kind of thing. Request library to get the web page. Beautiful soap to extract the text from web page, and we're going to use this particular model. Now you can go and explore a lot of sentence transformers model and see which is suitable for your application. We're going to use this one, which is 384 dimensional. Vector. So what I mean by that, so when you pass in a text inside this model, the output will be in this dimensional. Okay, we imported that model also. Now here is the function. This function take any URL, just like what we pass this particular URLs, right? It takes those URLs and simply use request library and get the whatever. This will be a plain HTML content we got from that particular web page. But now then we take that plain HTML content, and then we use beautiful sub library, and we use the HTML parser, and then extract the plain text out of it, or the, let's say, text. And this particular part, what it does actually, it removes any script tags. So I still see we used to get a lot of JavaScript inside it. So we remove all the script tag, and we get only now plain text. So by the end of this thing, we should get whatever the text you see here. Now, once you have the text, what actually we are doing, we don't want to insert this whole thing as a one document inside the vector database. No, no, no. We want to create the chunk. Maybe this will become one chunk, and this will become the other chunk, right? And then we will create the embedding for these chunks. And why it is important? Maybe the first thing, your embedding model can't take whole this document, sorry. So our embedding model might not take this whole document as the input to create the embedding, so it's better to create the chunk. Other thing is that even our question answering model wants some small snippet, not the whole document. That could be the one reason. What if the to answer your query, it actually needs to get two chunks. something from this document and something from this document. So it's always better that create small chunks so that those chunks can be combined to create and give you the good answer or the relevant answer for you, right? So this is what happening here. So we take that plain text and we decide we're going to have our one chunk of 2000 character. That's what we decided. So we're going to split by lines. So we're going through each of line, and what we're going to do, we're going to collect all those line inside this chunk. And when we are collecting that lines, we check, does if I add the line to my existing chunk, that what I have already collected, if it is going to exceed the max limit what I have, which is 2000 characters, then what I want to do actually, let's say if it is going to exceed, then I want to append that existing chunk what I have, and then I start with the new chunk. That's what this particular logic does, right? And then once you are able to get the chunk, this is going to return list of chunk. Now here chunk is nothing but this string of 2000 characters. So once we run this thing, we should be able to see what exactly we are doing with all this thing. And then this is the function which does all this thing what we just talked, right? So let's look at this. Let's say this is asking us to enter any web page url. So let's take this particular url, such in url, and then we will, not here, let's enter here. And then this is what, so I have some output already. Maybe I can clear that output, clear our output, right? So this is the length of the chunk that we just, so it had 104 chunks of, let's say, 2000 thing. How does one chunk looks at? Let's look at one of the chunk, and that chunk is nothing but the, let's say, whole text what we have. It is a big string of 2000 characters. Now we need to create some index. First of all, a Pinecone index. So let's go and create. So I have already one created one index called YT Tamo or U2 Tamo. Maybe we want to create one more index. So in Pinecone, you can create the multiple project. Inside the project, you can have a lot of indexes. So I have already one index. If you see, we could see the, but let's create the new index for this demo, right? That will be better. So let me go to the indexes and let's create one more index. Maybe we call it as, YT demo, maybe a second index or index 2. Again, 384 dimension. How we will decide what is dimension? Because we know the embedding model that we are using is actually of the dimension of, let's say, 384 dimensions. So that is what we are telling. And then different pod you can take, which for example, this is for better for storage capacity, this is for the faster queries. Let's say we are interested in the faster query. How do we want to match the vector? Let's say we're going to use cosine similarity for that. So let's create the index. So creating index is nothing but some kind of a data structure at the vector db side, where you can put your embeddings here. So we're going to put our embedding inside this index called yt demo 2, and we're going to use this particular index. Currently it is initializing. Don't worry about the terminology index and all this thing. It is nothing but some kind of a data structure which is going to store our embedding. So let's take this yt demo. That's what we're going to use now. And so we saw this is how we're going to get the chunk. Now we need an API key. So if you want to know where is your API key, you can get your API key from here. So you can simply copy the API key and you can get that key there. I have already put my key here. And then environment is also, it is the same thing what you see here. I think, yeah, here is, this is the environment, US West 1 GCP, because it is going to use, let's say, either AWS cloud or the Google cloud to create these instances. So we could saw that we want, let's say, GCP and the name of the index. So our name of the index is y2 demo. Let's, using this pinecone.init, we're going to give a key and the environment, and then we're going to see which index we want to access, right? So now we got the instance or reference to the index. Now let's describe the index, what already this index has. So this index is 384 dimension, but there is no vector inside this index. Now we have one more function which actually going to add data inside this index. What does this function does? It takes some data and the url actually. So url is just the metadata from where we got this data. This is the data, right? We scrapped a web page and then we got some chunk of text. So you could see this is a list of chunks what we got, right? So we're going to insert this list of chunks. So this function, this corpus data, is nothing but the list of chunks, and this is the url. So we want to store let's say url as a metadata. Again, if you haven't watched my Pinecone video, I would suggest go and watch, where you could see when you are storing the embedding, which we're going to calculate actually. So we can store some metadata from where we got this embedding. So we're going to store the title as a URL because we want to know, let's say when we retrieve this context here, what if we want, let's say there are multiple web pages related to Cristiano Ronaldo, and we want to know from which URL actually we are answering this thing. So maybe we can show this meta information. That's what we're going to do here. We're going to store the URL from which we're going to, and then the actual context, which is nothing but this text itself, kind of thing, right? So what we are going to do here again, this function is going to take let's say corpus data what we have, and this is the URL, and we're going to call index describe again what you saw here. Why? Because we want to give some numbering to them. So we want to know the existing total vector count. We take that ID. Why it is double? We don't need this thing. And then we're going to increment the ID, right? So this is what we're going to do. Take the corpus data, iterate through each chunk, and when we get that particular chunk, we're going to insert this information. You see, this is the information. What it has some ID, which is nothing but whatever the vector count plus 1. This is our embedding that what we are storing. So model dot encode is the chunk we are encoding, and we are converting into the normal Python list. This is nothing but your sentence transformer embedding. So what is model? Model is a sentence transformer thing what you have, and it actually creates the embedding for us. Okay, if you are not, if you want to see what exactly the embedding look like, so maybe let's copy and see, right? Let's say you don't watch that particular video, then I want to show you what's happening here. Let me take this thing and maybe show you what exactly the output of embedding. And let's take some chunk from here. Let's take this part something here. So I will show you this, right? So this is the text, and then we are simply converting it to the list, right? So let's run this thing. See what happened. Nothing but the text got converted into the numbers, a vector representation. That is something you could use, compare, calculate the cosine similarity. So that's what it does. Semantic, sentence transformer embedding. I would urge you go and watch this video to get the better understanding of all this thing. If I start covering everything in this video, this is going to be long. First of all, it is already getting boring because I'm not actually typing any code, and because if I start typing the code, it will take a lot of time, that keyboard noise and all these things. So that's why I try to have everything handy, and then I explain you what we are doing. So what is this chunk? The ID associated with the actual embedding, that what we just saw, and some metadata. This metadata is nothing but a dictionary that is going with the embedding that what we have. So when the embedding matches with semantic search, we can also retrieve the metadata so that we know something about, because you are actually storing the actual chunk, the text inside the metadata, right? So you definitely want to retrieve the metadata. And then this is one of the information we are storing, the title as a URL. You might call it URL itself, but let's say I modified the earlier code, so that's why I name it as the title. Let's run this function. Now we have already the plain text, and we saw that there is nothing inside the this is the text what we have, right? This is the list of things. See, and currently our Pinecone index doesn't have anything. If you go to the YT demo, and do we have any information? There are total vectors as 0. Let's go and run this function, which is what it is going to do, which is going to take our the text that we grab from here, and then the URL that we have, and it is going to insert inside our Pinecone. And inserting is called index.upsert is the method which takes the list of vectors that we want to, or list of chunks that we want to insert. So let's run this thing. It might take some time to insert, and once we insert it, we should see some count reflecting on the, let's say, the Pinecone console what we have. Should we go and check here? Yeah, you could see total vectors are 31. So it got reflect here whatever the vectors we have, and it is still running. Now we have 62 vectors, so the vectors are getting updated. Once it finishes, we will see how many vectors we got, right? Those vectors are is equal to 104 because the 104 chunks we have. Now it is 92, so it is inserting all the chunk. I think it has done, right. This took 34 seconds, and we got our 104 vectors here. Let's go back now. Since we have now information related to Sachin Tendulkar inside our vector DB, This function is actually help us to find the most relevant document. So what it takes your query. Now query is even nothing but the question that we're going to ask. Then it is asking the next parameter is how many such a relevant document you want to take. Let's say we only care about one chunk, which is the most relevant, right? So k is equal to 1. We take the query, we pass through the same model sentence transformer. We got the query embedding. Just like we have index upsert here to insert, we also have index.query to find the most relevant document, right? That takes the embedding of the query that what we have. Then how many top results you want to return, and do you want to include the metadata? Yes, because we are storing the actual chunk inside the metadata, so we want to retrieve that information, right? And this is the result we got. Now once we got that result, what we are doing actually, okay, this might become complex, but let's see what's happening. So we know that we're going to get two results, so we're going to iterate through those both the results. Okay, and from that result dot matches for that particular result, we're going to go to its metadata and take the context that what we have stored. So if you see, we are storing the context with the actual chunk what we have, so we want to get that context here, and we simply getting list of context. So let me run this thing and I will show you what exactly. So if I call this find match, you could see this is what results we are getting at a single match. So we are getting whatever the matching document. I think even the URL is one of the match we got. Let's see if I do here two things. So we should get two relevant documents. So this, why we get this two thing here? Okay, this is the URL actually, what we got, but where is the two document? We should have list of two things here. So this is the first element starting here. Where is the second? Yeah, first element is finishing here. This is the first chunk, and then we have here is the, I guess this is the second chunk or what, or am I making any mistake here? So find match will return. So this is the reason what exactly we are returning here. Let me go back and see. So this some kind of, this is the result. Okay, so result is a list first of all, right? Okay, we are returning actually a tuple. So we are returning this list, and then we are returning again this list also. Seems to be I made a mistake. Why would I want two things here? Okay, because I also want to retrieve the URL, that is the title, and then the context. Okay, that's what we are getting. So let's say we want only one matching. So what we are getting? We are actually getting a return a tuple which has actually the associated URL and the actual content. That's what we have it, because we are returning a tuple. That's why you see this is a tuple syntax, and each of them is actually a list. Each element of that tuple is a list, because you could have a multiple, right? That is why it is a list. Ideally, I would try to put like a two, because let's say we want to get two chunk. Now enough, we got the chunks, which is the relevant thing, but now where do we find the answer with respect to the query? So let's take the help of GPT-3. So we're going to use the simple prompt. We're going to say, hey, answer the question as truthfully as possible using the provided context, because we're going to give the context to GPT-3. And if answer is not contained inside the text, then simply say that, sorry, not sufficient context to answer the query. That's what we're going to do. So here is our code. This is how we are generating the prompt, which take the context, which is written by, let's say, a semantic search, you could say. We still have a lot of JavaScript. You can play around your, scrapping code to make sure you get the read of this particular stuff. And once we pass the context and the query, we are generating this prompt, which is nothing but the same instruction what we saw. We give the context and we say, hey, here is the query, now find the answer for it. And typical GPT-3 call, which take the prompt and we use the text DaVinci 003, and we should get the answer. So let's run this thing. And let's say okay, we're going to ask who is Amitabh Bachchan, like, and let's say what happens. And we got some result. And then do we want to see, yeah, so the good thing we're going to get some relevant, because we haven't put any threshold on the matching of the semantic stuff, so we still get some documents, that let's say might not the matching what we are looking for. So let's say this document still with respect to, let's say, Sachin Tendulkar, right? And what we do, then we create the context out of it. So we take all the chunks that we have retrieve and then make it as a single string and then pass it to the prompt. So let's print the prompt also so that you could see, what exactly the prompt is doing. And let me run this thing, and you see we are saying answer this question with respect to the context, and then we are putting whole big thing as a context, whole this information, and then finally our question, and then we pass that information to, let's say, GPT-3 for generating the answer. This is GPT-3 call, the function that what we saw. And it is saying it's a film. I think it got something related to Amitabh Bachchan inside the Sachin Tendulkar text. Let me see whether what reference it has for Amitabh Bachchan. Okay, it has something related to Amitabh Bachchan inside this. That is why it is able to answer this thing. But let's see if I ask who is Ronaldo. See whether it has anything. Okay, does it find any? Now let's say we're going to ask again and see what happened. Now it say it doesn't have any sufficient information because we don't have any information related to Ronaldo inside the right. And let's say now let's ask about Sachin itself. Who is Sachin? Okay, now let's use the GPT-3 and we will see what answer we get. And now it is saying, this is the GPT-3 call. Sachin Tendulkar is an Indian cricketer. So this is how things are working, right? Again, if you want to have a look at, this is a typical a GPT-3 call. Again, if you have watched my any of my earlier videos related to, let's say, GPT-3, it should be clear to you how to use a GPT-3, right? Now, what we did here, we have everything. Here we have, we can take the URL, we can make a request, we can get that HTML content, create the plain text, create the chunk, and then finally insert that information inside our Pinecone index that we just created using this particular function. And we are when we are storing that chunk, we embedding, then we store a metadata with that URL and also the actual chunk, because we want that thing to give a GPT-3 to give us the answer. And finally a GPT-3 call what we have it here, right? And then we can simply take all this thing inside our Streamlit application. So if you see our Streamlit application, what does we have? So we have first this title, then we have a some kind of a radio button. We choose whether you want to ask a question or whether you want to update our database, right? And depends on that thing. If it is want to ask a question, we're going to ask, enter the queries. If you look at that, this is our Streamlit header, and this is we're going to give a radio option whether you want to choose a task. Sorry, what task? Ask question or update this thing, right? And depends on what user has selected, we will ask them for further information. If it is update database, then we will say, hey, enter the URL that you want to update. And then if it is query question, then give us the query. Now, once we got that, one of this option, if it is updating database, what we're going to do? We're going to call out that function scrap text from URL. So we put all these utilities inside the file called utils.py. Same function. I just copied from our, let's say, collab notebook. And what it does actually, it gives us those list of chunks. And then we call add data function, which is related to our vector search utility. So this is inside the vector search, same function we're going to add. And then we have also function for the finding the match, and that's what we do, right? So here we updated the DB, and then that's what is happening here. So when you want to update the DB, you're going to give a, let's say, Cristiano Ronaldo, and and this is what going to happen. So if we go to the terminal, let's see if terminal is anything happening. Yeah, you could see we are inserting a lot of batches inside the vector database. So this is what the updating is happening. Same code, but just we have now some interface so that we can uh, play around it. And similarly, when you ask a question, we want to find the matching thing, right? And that is what again we call say vector search. We find the matching thing which is here, and then once we got those resulting documents, we just create the big string using, let's say, we concatenate those paragraphs as doubles or two new line characters. And then eventually we have expander here, which is nothing but this. When we ask a question, there was expander. Okay, let's wait, it is still, I think this Ronaldo page is I think okay, it is a very, I think big page, very long page, and that is the reason it's taking a lot of time to. Let's see how many vectors we got here. Should we refresh it? Oh no, because it might be inserting in the other index, right? Our index is wrong here. Where is the index? So we have our semantic search, right? Which is using our old index, I guess, is YT demo. It has to be YT demo 2. Anyway, I just wanted to show you the purpose of that particular Streamlit code. Now the database is updated. If it was the ask a question, that's what we're going to do. Cristiano Ronaldo, or maybe let's say we got say awards something. And then when we submit this thing, you see this is the context that we retrieve from, and this is expander what you see on the main page. This is the expander if anyone want to see the context. And once we got the context from semantic search, we are creating the prompt using our GPT-3 thing, which is in the question answering, getting the prompt and then making the GPT-3 request, and then whatever the answer we got, we are simply displaying here, and that's what you see here as the success message, that whatever the award it got, right? I hope this video, I know this got longer, and maybe like I would say, I could explain the code in much more depth, but I think I have already covered all this information in the other videos. So I just wanted to give you the glimpse of putting all this knowledge together. Your let's say embedding knowledge, your vector database, your GPT-3 Streamlit application, web scraping, everything when you combine, this is what the powerful application you could build. And I'm telling you, this is the hottest area currently. Whatever the NLP task I'm getting, a lot of this task involve the semantic search and then kind of GPT-3 kind of combination. Now here we are using sentence transformer. You could use GPT-3 embedding also. So I think if you do this thing, do this hands-on, because I'm going to share code with you, right? So you have everything with you to try out the things, and I'm definitely sure you can upgrade your skills and you can build something for yourself. Like you might want to I personally use Notion for all these things, and I might want to index my Notion itself and then ask any queries with respect to whatever the notes or documentation what I have. You could use it for your personal use, you could build something for your company, you can create something and open source it, right? So this is very exciting time. We have a lot of technologies to do a very amazing and exciting stuff. So I hope you found this video useful, and let me know inside the comment if you want to make some other version of this particular tutorial, or do you want me to create something else with respect to, let's say, NLP or whatever the state of the art things happening around, right? Okay, thank you very much. Bye.